Hello and welcome to another video. This is going to be the first multiple regression analysis that's going to be based on more than one single independent variable, more than one x. If you take a look at this data file, it's an Excel file that I downloaded gratefully from this website. At least the domain is edu, which is an educational domain. Please make sure when you download something from the internet, if you want to play with the file that already exists, to make sure that you either run it through your virus checker or make sure that it doesn't have any macro attached to it. Uh, there is no guarantee that you might get like anything even from some reputable site that might some viruses attached to it. Uh, Again, the best common sense is to consider the source where you're getting it from. So usually educational institutions don't have that much problem, but there is no 100% guarantee of anything in life in general. Anyway, to make it a short story, I wanted to go ahead and show you that this is actually going to be a list of data that observed in the real world based on the fact that this company is trying to assess the value of a building they're trying to buy. This commercial development has multiple variables that are going to be factors whether this company is going to decide to buy it or not. So if you take a look at the variable that we're going to be considering in order to assess the value of y, this is the dependent variable. This is the one that we're going to predict. And these are the predictable, the 11 observation. The first one is floor space in square feet. And the second one is the number of the offices in that building. The third is going to be the number of the entrances in that building. And the fourth, rightfully so, is the age of that building. How old is that building? In years, of course. So we're going to have to look at four different variables. X1, floor space in square feet. Offices, the number of the offices in that building. Entrances, the number of the entrances, and the age. And this is what they found out by calculating actually the SS value based on these 11 uh, different observation. Now we're going to see if we're going to be able to use this data that has been observed, not calculated, observed. I used the word calculated earlier, it was wrong. We are going to do the calculation in the data analysis in order to come up with a model that is going to predict for us the future purchase of a floor space with 2,500 square feet, 3 offices, 2 entrances, and 25 years of age. So this is an example that we could actually use to predict that. Of course, we could predict any sort of data, but that's the example that came along with the data file, which I'm going to be using this cell in order to come up with the calculation. Also, I'm going to be proactive by selecting the cell in order to really initiate the display of my multiple recognition here. Multiple linear recognition is going to be displayed starting with this cell, just to give me a peace of mind. I know where it's going to be. So I'm going to go to data. I'm going to data analysis, and I'm going to click on regression. I've been playing with regression for a while, so it's already there. It's going to ask me where is your input range. I'm going to include the label because I'm going to mark the label. It's all the way up to here. We have 11 observations from 2 to 12. And the input x's, I'm going to go ahead and highlight all of them along with the label all the way here to this one here. And the output range, I'm going to go ahead and put it now instead of in 1, I'm going to put it this one here in 3. I could go ahead and click on residual. I could even click on the residual plots, but I don't like it. As I said in a previous, I could do my own much better. And I'm ready to actually go ahead and run it. I'm going to click OK. And notice, immediately give me the result. The only thing now, I have to have the knowledge that will allow me to accept the model and look for every prediction value and to see if it's feasible, if it's what we call significant, and if it's not significant, we have to discard that variable. So when we run this, we run it at the confidence of 900 level of 995%. So we're going to use alpha as 0.05. That's what's going to be the factor for determining the significance of our model. I'm going to go ahead and make the model a little bit bigger so I'll be able to see it, and maybe even bigger than that so I'll be able to enjoy the view without having to suffer through scrolling back and forth. Okay, this is my R square. Okay, we could go ahead and use adjusted R square because we have multiple variable here. They're very, very high. I mean, my God, this is almost 1. So there is a huge correlation. It's almost perfect correlation. So we could go ahead and continue to look for that. This is number 1. Okay, this is number 1. This is what you're going to be looking at when you're trying to do your analysis. We passed this. If it's going to be 0.12 or 0.19, you might have to really rethink about what you're dealing with. The second one is going to be this value, which is going to be the significance of f, which is the significance of the whole model itself. Oh my God, this is really very, very low. So I could go ahead and say if this one here is less than 0.05, continue, otherwise no need to do anything else, reject it or some, we use the word accept and reject. No need to continue. So let's go ahead and see that, of course, in an if statement. All right, let me go ahead and see here. Is it going to be here less than, sorry, less than 0.005? Of course, it's much less than this. This is extremely small value. We're talking about raised to the power of 10 to the power of, 10 raised to the power of minus 7, which is extremely small. Let's go ahead and look at those 5 values. If any of those values is greater than the 0.5, we're going to be in trouble. I could go ahead and just for my peace of mind, I'm an Excel user, I like an evidence, I like sometimes things in Word, I will say here if any of those, here we go, is less, if it's going to be less than 0.05, okay, we're going to say great, okay. Otherwise, very bad variable, because we're going to remove that variable. And here we go. Okay, we're going to go ahead and click that 5 times just to keep it in mind. All of them are okay. All of them are going to be okay. Not only this, if I want to communicate this to another person, another manager who has no clue what is statistical analysis, what is multiple regression, and they have probably used Excel for a year, so they'll be able to see it in much more meaningful when we use Excel, when we do it with an if statement. That's my personal preference. Don't use it unless you're really convinced with that. Some people have those values. I mean, if you're doing a research paper, they're not going to really concerned with their statement. They want to look at the actual p-value in order to believe you. So obviously the model itself is perfect, and it's going to be able to assure us that whatever we're going to be using it for is going to be a valid. There is a relationship between those variables, and the regression proved to us that everything is going to work for us. So what are we going to do? We're going to go ahead and continue to predict for those values. I'm going to go ahead and make it a little bit smaller, so we'll be able to see what we're going to assist, what's going to be the assist value based on these values for the different variables. So we're going to start with equal sign. The very first thing you're going to do is to come up with the intercept. That's the y-intercept. Plus, it's going to be this is the coefficient for the floor space. I need a little bit of water, so I'm going to take a sip of water here. My tongue starts sticking to the top of my mouth. All right, so this is much better. This is going to be multiplied by this. I mean, I'm already having a bad accent, so you can imagine accent with a lack of movement on my mouth. All right, here we go. We're going to get this one here multiplied by, sorry, not plus, multiplied. Here we go. And plus here, this is the coefficient of the entrances. We're going to go ahead and do that. Multiply by the value of x3, meaning 2 entrances we have. Then finally we have the age, and I'm going to go ahead and re-examine the age because the age is having a negative what do we call it, a coefficient, which is a negative slope. It makes sense. If the age of the building is higher, it's going to reduce the assessed value. So this is basically where we're going to really make some sense of the data. So here we go. The higher is the number of the years concerning the age of the building. It's going to be this is basically what I had from the model I downloaded. So it's going to be more of a proof to me that what I did is correct, but I'm not going to rely on somebody else's work because I have to prove to myself through my works that everything that I've done is correct. Again, let's go ahead and examine these. Okay, 4 variable with 4 intercepts. Not sorry, for slope. There's only one y-intercept here. The coefficient, all of them are called coefficients. So I'm going to go ahead and quickly examine all these. Notice that the floor space is going to have a good significant, 27. It's going to, the number of x's like xy, which is the square foot, is going to increase the value of that building with a 24/7 dollar. When we talk about the number of the offices is very, very significant. It's really the largest significance of all because it's going to actually increase the value of that building with 12,529. Okay, the number of the entrances is, of course, it's a positive slope, meaning it's going to add more to the value of the building, but it's not as significant or it's not as large with its impact on the overall assessed value, just like the number of the offices. Of course, that makes sense. You know, the number of the offices is going to be a lot much more important, put it this way, than the number of the entrances. Office is bigger in value than the entrance. And here, the age is a negative slope, which means if we added 1 more year to the age of the building, it's going to subtract minus 234. So when we talk about, how the model came, we can immediately, by looking at these values, all these values, and see which one is going to impact the overall assessed value, but which one is going to impact it more than the others. If all of these are zeros, if x1 0, x2 0, x3 is equal to 0, x4 0, then we're going to be only left with the coefficient of 52,317 before we even start. So we even start, this is going to be the intercept. That is the lowest prices that you're able to be handled before we even think about the floor space in offices and entrances and the age. I hope that was helpful. The only thing I would ask you to do is to go ahead and use the file. I'm going to go ahead and send you the file, and you'll be able to, of course, download it and play with it and enjoy your understanding it through the process of running the data analysis and see how it's going to work for you. Thanks a lot for watching this video. I hope to see you in the next one. Take care.